Howdy there once again, YouTube. I'm Ben Ferraiuolo, and I am back once again. Please like, share, subscribe, and click the bell. Also, please come visit my website here. It is monitorsize.weebly.com, monitorseis.weebly.com. And please do not put www. in the URL. This website contains a lot of information on what I have already learned, including how to tell the difference between different types of earthquakes, how to download and analyze seismic data, and much, much more. If anyone is truly interested in monitoring seismic hazard areas, this website is a must. However, a lot of what I have learned has come from professional publications, information and data provided by IRIS, and top-notch seismic school books. However, some of seismology still makes my head spin. By the way, I have created right here a seismic image web recorder archive. Remember, a web recorder is simply the chart or graph that seismograms are displayed upon on the internet. I have created an archive for Long Valley, Lassen Peak, Newberry Caldera, and Mount Rainier. This is because their online web recorders are not archived, and they're kind of hard to find unless you use the program Swarm. Now, Yellowstone's online web recorders are archived by isthisthingOn.org/Yellowstone, so I will not archive the Yellowstone web recorders yet. If that website ever goes down, then I'll start archiving them. Don't worry. Let's go to Long Valley real quick. For an example, here are the archived images of select seismic stations for Long Valley. All I do is download a whole day's worth of data from 0 UTC to 2359 UTC, plug it into Swarm seismic software, and create my own web recorders and upload them to my website. Sometimes seismic stations glitch in and out. Sometimes they completely disconnect, and other times they work just fine but transmit garbled data. However, if you truly wish to analyze a certain seismic event, I do suggest learning how to download seismic data and learning how to analyze it in top-notch seismic software, such as JamaSize, Swarm, or Waves. You could do that by watching certain videos on my YouTube channel, or just simply peruse my website and learn how to do it all yourself. You actually can go to more seismic software. Here's the downloads. You can go to how to read seismograms, how to use the seismic software, and how to download data and understand UTC, and multiple other different things. And you can even go to About Me to learn about me. You know, it'd actually be amazing if I could teach someone else all that I have learned. It'd be nice to have an acquaintance who can help me analyze data quicker. Now, the last link in the drop-down menu says Used Station Locations. This shows the respective location of all the seismic stations I used to download the data for these archives. Now here we are back at Ben's blog, my Seismo blog. In this video I would like to talk about 3 earthquake swarms that occurred at Yellowstone, and one interesting low-frequency event that actually just recently occurred at Mary Lake. In regards to the 3 swarms, 2 occurred at West Thumb, with the earthquakes within both swarms occurring in a very rapid succession, and the 3rd swarm occurred directly under Straight Creek, near Maple Creek. All 3 swarms were not major, but the 2 that occurred at West Thumb have me concerned, since rapid succession events have been occurring near West Thumb since around summer 2018. I always like to keep my eye out for rapid succession events and spasmodic events, since they usually indicate some type of rock break sequence. Usually magma is the culprit, but you never know. The rapid succession in the July 5th event, which I talked about in multiple videos, and the August 26th event sometimes included 4 or 5 earthquakes within just 1 minute occurring multiple times. Now the magnitudes were very small, but regardless, they still were earthquakes. Now if the swarm carried a higher frequency with earthquakes occurring about 1 or 2 per 3 minutes or so, I could say yeah, it might be tectonic, even though it still could be volcanic in nature. However, West Thumb is of the most interest to me, and, as seen in my recent volcano update, uplift does seem to be starting back up once again, directly atop the magma reservoir. If true that uplift is occurring again, this could mean larger earthquakes and earthquake swarms are approaching for Yellowstone, but I do suggest people keep an eye out for swarms breaking out near West Thumb. Now let me start in order. So, let's begin with the earthquake swarm that occurred on August 21st, 2018. The August 21st, 2018 Yellowstone Swarm. Hey guys, welcome to my first blog post on my new website. Feel free to comment below, of course, after clicking read more in this post. I will simply talk about the minor earthquake swarm event which occurred on August 21st, 2018, near Little West Thumb, Yellowstone Lake, Yellowstone, Wyoming. As always, please click read more on any of the blog posts to read more, or you could always click the title. On August 21st, 2018, from 7:53 UTC to 8:33 UTC, 12:53 a.m. to 1:33 a.m. Pacific Time, a small but interesting earthquake swarm appeared at Yellowstone. Seismic data was retrieved from the 3 seismic stations which were closest to this event, H17A BHC, YLT-EHC, and YML-EHC, merging all 3 data files into the seismic program waves and cross-correlating only P-wave arrivals. I came to the conclusion that about 20 identifiable earthquakes occurred within this 40-minute time frame. Something also interesting to point out is notice how it's a 40-minute time frame. Well, on July 5th, 2018, the earthquake swarm at West Thumb was a 40-minute time frame. Isn't that weird? That's very odd. So there were 20 identifiable earthquakes from 7:53 to 8:33 UTC, with one lone earthquake occurring at 12:52 UTC. Most earthquakes were extremely small, most likely registering between negative 0.1 to 0.4, with actually some of them were around 1.5 to 1.8 though, a few of them, and occurring beneath the northern tip of West Thumb Yellowstone Lake. However, there were some earthquakes that were larger, but sadly only 3 earthquakes were reported for this event, seen in the image directly below. There were definitely 15 to 20 earthquakes within this event. Don't believe me? Simply use waves, merge all 3 data files, email me if you want them, zoom in until the waveforms are spread out enough to identify P waves, and count all the P waves that appear on all 3 stations. Definitely at least 15 to 20 earthquakes. I am not saying all of them were locatable, just that they were identified as actual earthquakes due to their travel time to the 3 nearest stations. YLT seems to be the seismic station that was closest to this event. And you can see the earthquakes here. The only 3 that were reported on West Thumb. Again, sadly, they only reported 3 earthquakes for this event. Now, they said the largest event was a magnitude 1.8. The amplitude of the largest event did seem to indicate a magnitude of 1.8 to 2.0. The 3 images below are the seismograms from this day showing the earthquake swarm. This post continues below the 3 images. Remember, the swarm lasted from 7:53 UTC to 8:33 UTC, with one lone earthquake occurring at 12:52 UTC. As always, UTC is the time period used on the right. You see a bunch here, one there, few here, and one down here. Alright, H17A and YML. Although there were no low-frequency earthquakes spotted, sometimes a sign of magmatic resonance or volcanic gas release within a small space, something you would most likely see during a magma injection event, I personally believe this was caused by hydrothermal fluids being aggravated by something. What else is down there besides dirt, rock, and hydrothermal fluids? Magma! I do not believe this was an intrusion event, but due to the rapid succession of earthquakes, it seems tectonic activity alone was not the cause. I do think it was some type of rock break event. Including the earthquake swarm on July 5th, 2018, there have been 3 separate rapid succession earthquake swarms right at West Thumb Yellowstone Lake, right near the same area. The July 5th event seemed to contain the fastest occurrence out of all 3 events, I believe. I need to go check that back out. I haven't looked at the July 5th event for a good week. It is still my opinion that the July 5th event was caused by magma injection. I will soon be doing an article about that within the Seismic Events page. The Seismic Events page really is the least constructed page out of all the pages on this website. The 3 rapid succession earthquake swarms at Yellowstone occurred at Little West Thumb on July 5th, 2018, August 21st, 2018, and August 26th, 2018. So what is going on with West Thumb? Why do the earthquakes occur in a farther rapid pace than anywhere else within Yellowstone National Park? I do not have an answer to that, yet. The images below are from the event on August 21st, 2018. Please always remember to keep time frame into account. Need additional data or images regarding this event? Please feel free to email me at any time. So I got 3 images right here. You can tell there's 1, 2, 3, 4, it appears. 4 events within about a minute. Yeah, look at that. So this is what was happening. During a lot of these rapid succession earthquake swarms, you could see multiple earthquakes. Although they're a little small, multiple low to mid-frequency earthquakes happening in just a minute. Which to me is very odd. Usually with tectonic activity, they're spread out a lot farther. So I'm thinking it's definitely some type of rock-breaking sequence. So wasn't that interesting? Again, please visit my website to check all this stuff out for yourself. Now, let's talk about the other 2 swarms real quick. Here we are at the other article. 2 recent Yellowstone swarms. Including the minor earthquake swarm at West Thumb on August 21st, 2018, what I just talked about, there have been 3 earthquake swarms already for Yellowstone in the month of August. They were not too major, but just like before, we see the earthquake succession at West Thumb occurring at a farther rapid pace than other areas at Yellowstone, sometimes multiple earthquakes within 1 minute. Why? Who knows, but it is my opinion tectonic activity alone could not cause the West Thumb rapid succession swarms. Remember guys, I'm still a beginner at all of this. Seismology is extremely interesting to me and I cannot wait to make a career out of it. I will be talking about the swarms for August 26th and August 29th through the 30th in this post. As always, please click read more to read the rest of this blog post. Or you can always just click the title like I did. August 26, 2018 West Thumb Swarm. Again, you could see plain as day the rapid succession. The August 26, 2018 West Thumb Swarm as shown on Seismic Station YLT. On August 26, 2018, at the northern tip of West Thumb at Yellowstone Lake, the same exact location as the July 5, 2018 possible 40-minute intrusion event, a very interesting earthquake swarm occurred. Many features seem to indicate it might be a continuation of the July 5th event, one I have always suspected to be a cause of a short burst of magma which was injected into above cracks or a pre-existing fracture, between 3.8 and 4.8 kilometers in depth on the northern tip of West Thumb. On 2018-8/26, from about 20:05 UTC to 22:17 UTC, that's 1 p.m. to 3:17 p.m. Pacific Time, I was able to identify 54 earthquakes within a 2-hour and 12-minute time frame by cross-correlating P-wave arrivals using the program WAVES and 3 of the closest seismic instruments, YLT, YML, and H17A. Note, I was not attempting to determine earthquake locations. I was simply determining how many earthquakes actually occurred near these 3 stations. Many earthquakes in the swarm were most likely not able to be located, due to approximately 60%, not an exact number, of the earthquakes occurring at very low magnitudes, magnitude negative 0.3 to probably around magnitude 0.5. Of course, others were above that, around the 1.3 to 1.5 range. As seen in the image directly below, only 14 earthquakes were reported for this location and time period. You can also see it is virtually the same exact location as the July 5th event at the northern tip of West Thumb, also shown below. Only 14 earthquakes reported for the 2-hour and 12-minute swarm at West Thumb on August 26th, and here is the location of the July 5th intrusion event, which I believe was intrusion. I believe this is a continuation of that event. So yes, 54 earthquakes were confirmed for the August 26, 2018 earthquake swarm. 54 earthquakes within 2 hours and 12 minutes. Now, only 14 were reported, with the largest being a magnitude 2.8 at 4.3 kilometers in depth at 2032 UTC. Many of the earthquakes in this swarm carried a mid-range frequency, with some earthquakes appearing to be hybrid earthquakes. See earthquake type examples. To the left is a picture of the earthquakes, the one highlighted blue being the largest event. The image directly below is the waveform and frequency analysis of this one large earthquake. Note the dominant frequencies below 10 Hz. In retrospect, high-frequency tectonic earthquakes far exceed 10 Hz. You notice that? In my opinion, this is a good-sized low-frequency earthquake. That's my opinion, guys. Now, real quick, I want to show the tilt meter plots for borehole 944, which resides right near West Thumb, and borehole 208, which resides on the northern tip of Yellowstone Lake. The first plot shows the past 30 days of tilt at B944, and the second plot shows the past 30 days of tilt at B208. Now, remember when viewing a plot, chart, or graph, even in regards to mathematics, you must always look at the information given on all sides of the chart. For example, you will notice the tilt meters record tilt in microradians. The amount of microradians labeled on the left can change drastically in response to large changes in deformation, so you must always look at the microradian extent and the time period at the bottom before you look at the plot itself. Tilt meters are different than GPS and deformation instruments. GPS instruments record the way the ground is moving, the direction, in all directions, including vertical uplift subsidence. Tilt meters, on the other hand, detect minute changes in the shape and slope of the ground where the tilt instrument is set up. Actually, so if the tilt meter seems to be rising, or the angle is growing, and tilting away, that means it is on the slope of a possible bulge going outwards. So kind of imagine let's say the ground is flat, right? And let's say you blow up a balloon under it, and it starts to balloon and expand, and like this dome starts rising. Well, if you put something right on the slope, the farther that dome rises, the more angled the tilt meter will be. You understand what I'm trying to say? USGS actually puts it quite well, stating tilt measurements have been used to monitor volcanoes in the United States since the founding of the Hawaiian Volcano Observatory in 1912. When magma accumulates beneath the ground, causing the surface above to inflate, the slope of adjacent areas will usually tilt away from the center of uplift. See, that's what I was trying to say. Conversely, if the ground deflates, which is subsidence, as a consequence of magma draining from a subsurface reservoir, the slope of adjacent areas will tilt towards the center of subsidence. Like a carpenter's level, an electronic tilt meter uses a small container filled with a conducting fluid and a bubble to measure a change in slope. Tilt is measured in microradians, which is a small fraction of a degree. 1 microradian, guys, listen to this. 1 microradian is equivalent to 0.00006 degrees. Wow. But still, though, it might not seem like a lot, but when you're talking about a huge area of land like at Yellowstone, even the smallest increase in uplift will show on the tilt meters as it starts to angle away from the uplift area. 1 microradian, again equivalent to 0.00006 degrees, is approximately the tilt caused by placing a dime under one end of a beam that is 1/2 mile long. The Volcano Hazards program uses a variety of tilt meter types, but instruments placed in shallow boreholes, 1 to 6 meters or 5 to 20 feet deep, produce the best results because the sensors are insulated from noise that is common at Earth's surface. For example, the changes in temperature and pressure. Now they're talking about tilt meters, not seismographs, guys. Now when viewing tilt plots, including the ones shown directly below, please keep the information and explanation in mind. Here's borehole 944. Yeah, I'll talk about that in just a second. I don't know what's going on there. A little weird. Here's borehole 208. Sometimes global large earthquakes, such as the 8.2 in Fiji, can affect the tilt meters slightly. Now please take a look at the borehole 944 tilt plot. Right up here, yeah, 16 microradians, 32, 48, 64, 80. If this is true, and I'm really hoping this is a glitch, I really am. Because if this is true, there is some massive uplift going on near borehole 944, which is actually, surprisingly, kind of close to West Thumb. It's not at West Thumb. It's not on the northern tip of West Thumb like the earthquake storms have been. It's south of there, but still, it's close. So I don't know what the hell is going on here. Very odd. I'm really hoping it is a glitch. If it is not a glitch, then we have some severe deformation occurring at West Thumb. However, I try to stay optimistic. It is my firm belief that this event is a continuation of the July 5th possible magma intrusion event. Some of these earthquakes that occurred happened in such rapid succession. For example, 4 earthquakes in 1 minute happening multiple times, that it leads me to believe that this was another case of short-lived magma injection, most likely protruding into the same weak spot as it did on July 5th, if indeed magma intrusion is the case. I always try to keep my options open, guys. West Thumb has a pretty interesting geyser system as well. I have heard nothing about West Thumb Geyser Basin lately. If anyone has any information on any geysers or pools that have dried up there in the past year, please email me immediately. The gallery below contains images of random interesting events within this swarm, and the helicorders of the 4 closest seismic stations I could find data for. Regarding the waveform and frequency analysis images within the gallery, the analysis window time frame is set to 1 minute on most seismic images. Please notice the amount of earthquakes that were occurring within such an amazing short period of time. After the gallery below, I will talk about the August 30th earthquake swarm near Maple Creek, Yellowstone. Yeah. Woo-wee! August 29th through 30th, swarm near Maple Creek. You can tell they do not occur in such rapid succession as they did at West Thumb. From about August 29, 2018 at 17:19 UTC, 10:19 a.m. Pacific Time, to August 30th, 2018, 04:47 UTC, 9:47 p.m. Pacific Time, an earthquake swarm appeared far northwest of the most recent earthquake swarm, which did occur at West Thumb on August 26th. By using the P-wave cross-correlation method using the program Waves, I was able to identify 35 earthquakes for this time period and location, near Maple Creek, under Straight Creek, within about a 12-hour period. 35 is the number of earthquakes that occurred near this area and time period, not the number of earthquakes that could have been located down to the latitude-longitude. The seismic stations I used for cross-correlation were B950, YMC, YHH, and YPM. The images below show all earthquakes that were reported for this location and time period. The image zoomed into the earthquake swarm epicenter shows it occurred right below Straight Creek, if you know where that is. The largest event was reportedly a magnitude 2.4 at 4.8 kilometers in depth at 1944 UTC. The earthquake swarm was concentrated within a very small area. It is my opinion that this event was caused by pressure from the local hydrothermal systems on the fault zones which lie near Straight Creek. However, I must say some of the earthquakes within this swarm did have dominant frequencies around 7 to 8 hertz or so, in my book making them mid to low frequency earthquakes. As seen in a second, pure tectonic activity usually carries dominant frequencies around 10 to 15 hertz. Now, I was incorrect. I should have said 15 to 20, because usually it's 15 to 20, not 10 to 15. That's my bad. I think I made a mistake there. At times, exceeding that of what we saw during this particular swarm. Of course, since I am not a professional, that is my opinion, and it could be totally incorrect. I did identify 35 earthquakes within about a 12-hour period. Of course, some could not actually be located due to their small magnitude. But compare that to the 54 earthquakes within 2 hours and 12 minutes on August 26, 2018 at West Thumb. The image below is the seismogram and spectrogram of the largest event reported. Now, to show an interesting difference, the image directly below is of a tectonic-only event that occurred on July 16, 2018 near Yakima, Washington, eastern Washington. This earthquake is what you would consider a typical high-frequency tectonic event. There are no known magma sources anywhere near this area. To get an idea of what a low-frequency or mid-frequency event looks like, it is always good to compare the spectra, spectrogram, and seismogram analysis of one earthquake to one that you know was caused by tectonic forces alone. Kind of helps you get the idea of what caused an earthquake. Not that you could tell a cause just by comparing, but it definitely helps. Check out the difference between the image just below and the image just above this text. So compare this and this. The time frame allotted in both images is the same. You see the difference? The time frame is the same. Everything, all settings are the same for these images. But you notice the difference? Notice the drastic difference. Yellowstone Caldera is a very dynamic volcanic complex. That is why studying seismic signals at Yellowstone is my passion. The gallery below is full of images from this earthquake swarm. Please click on an image to enlarge it. My next blog post will be my second monthly volcano update. Thank you for your time and enjoy. And I already did the volcano update. So, as you can see, the swarms were not major, but the rapid succession characteristics of the events at West Thumb are of great concern to me. Finally, let's talk about the recent low-frequency event that appeared to have occurred near Mary Lake. So let's go to low-frequency event near Mary Lake, Yellowstone. Oh no. September 3rd, 2018. The seismogram and spectrogram plot above shows a possible low-frequency event that occurred somewhere near seismic station YML, Mary Lake, from 9:29 UTC to about 9:32 UTC. You can see an event here, 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 and here. Now, this looks like surface noise. I thought it was surface noise. Okay, this first event right before the low-frequency earthquake, which is this is the low-frequency earthquake I was talking about. I'm talking about this earthquake right here. It actually resembles wind in many ways. However, wind cannot send a specific signal over miles and miles. Don't know what I mean? Please continue by pressing read more. Or you could just press the title. And that's what I did, so it opened it up. Alright, distance from YML to borehole 950 is about 8.25 miles. Alright. Above is Google Earth, showing the distance from YML to B950 is about 8.25 miles. Now, why is that important? Well, this one unknown tremor event, so guys, we are first talking about just this right here. We'll talk about this earthquake in a second. I'm going to talk about this. Well, this one unknown tremor, quote-unquote, event that occurred before the low-frequency earthquake appeared on only 2 seismic stations within the entire WY network, YML and B950. So it'd probably be hard to locate, almost impossible. I first thought it was surface noise, but then I noticed the travel time from YML to B950 and the P-wave arrivals conclude that this was an actual seismic event. Of course, it was not major, only maxing out at about 2,000 amplitude count. It also did not carry the characteristics required to label it harmonic tremor. However, it does to be a kind of tremor of some sort, carrying a mid-range frequency. Could this possibly be a hydrothermal tremor? I don't know. but it has a mid-range frequency. Now, if it was carrying a low frequency around 1 to 3 hertz, then I'd get scared, because usually that's harmonic tremor. But this does not appear to be. I don't know what this is. At least we know it is not surface noise, because it traveled from YML to B950, and that's 8.25 miles. There's no way surface noise can show up on both. Another view of the tremor, quote-unquote, that took place just prior to the low-frequency earthquake. Notice that it peaks at about 15 hertz. Very odd. Here's another... Oh, these two are of the low-frequency earthquake. The two images above, which have no caption, this one and this one, are of the low-frequency earthquake that occurred right after the strange, quote-unquote, tremor event. You can tell this can most likely be categorized as a low-frequency earthquake. Notice it barely exceeds 15 hertz and appears to have dominant frequencies around 5 to 10 hertz. In retrospect, most high-frequency tectonic earthquakes can exceed 25 hertz, even at small magnitudes. And you can see I tried to mark the P and S wave arrivals. I tried to, at least. And where I couldn't find S waves, all I did was just mark the P wave. The two images directly above show one other earthquake that occurred just a minute or so after the low-frequency earthquake. I attempted to locate the P wave, always marked with a black line on waves. I attempted to locate the P wave on YML and B950 to prove this was also not surface noise. If this weird quote-unquote tremor event that occurred before the low-frequency earthquake and this earthquake shown in the two images directly above were surface noise, then it would not travel from YML to B950 in 2 to 3 seconds. 2 to 3 seconds is about the travel time it would take for seismic waves to reach B950 if generated from near the Mary Lake area. Notice that? Now, how do we know this odd tremor, quote-unquote, event in the beginning is not just a teleseism? Well, usually a teleseism would carry a lower frequency and, 2, appear on MCID. Seismic Station MCID, Moose Creek, Idaho, resides just on the southwestern tip of Yellowstone National Park. It is one of the best seismic stations at Yellowstone for detecting teleseisms, global distant earthquakes, usually magnitude 5.5 and above. But even so, let's check MCID and compare it to YML to see if it was a teleseism. Nope, doesn't look like it. It's the same time period and time frame. Nope, doesn't show. For this one image, YML is the top web recorder and MCID is the bottom web recorder, are both set to the same time frame and time period. If it were a teleseism, the seismic signals would have appeared on both seismic stations around the same time, since these stations are not too far from each other. I mean, they are pretty far from each other, but in regards to a teleseism and a distant earthquake, they're not that far from each other. Here in the WAVE seismic program, I have B950 up top, MCID in the middle, and YML at the bottom, all lined up for the same time period. You can see both the odd quote-unquote tremor event and the low-frequency event appears on borehole 950 and YML. However, it does not appear on MCID, where it should appear if it were a teleseism. And plus, the P wave arrival times do indicate it occurred somewhere within the caldera, most likely near Mary Lake. So I was very intrigued by this one little event. This event most likely took place about a couple miles deep, just a few miles from YML. YML Mary Lake showed the strongest amplitude count, and the PS waves arrived at this station first. Interesting, huh? If anything else develops, you will be the first to know. Well, I'll be the first to know, but I'll tell you guys. God bless. You know, it's always good to keep a close eye out for these things. Now, I think the current number of steamboat eruptions is around 16 to 17, I believe. I was hoping we would break the all-time yearly record, but it seems that's not going to happen. However, you never know. The record is currently 29 steamboat eruptions in the year 1964. Oh, look, I caught it right at the end of the eruption. Aww. Well, that is it for now, guys. Please don't forget to check back to my website daily, monitorsize.weebly.com, monitorseis.weebly.com, for updates, new blog posts, and new content. You may think it is just another website, but you'd be surprised. It only takes 2 minutes of your life. So there were multiple earthquake swarms in August at Yellowstone. However, they were not that major. It is not the magnitudes of the earthquakes that concern me, but the rapid succession of the 2 earthquake swarms that occurred on the northern tip of West Thumb. I think I know where this is heading if earthquake swarms continue with the same characteristics in the same location. It is just an unproven theory right now, so I will let the beans spill if activity follows my current projection. Remember to please like, share, and subscribe if you like this video. If you ever need anything, any help analyzing data, or any help gathering seismic data or web recorders from around the globe, please do not hesitate to email me. I will always stand for the truth no matter what. Why? Because truth is hate or fear to those who hate or fear the truth. God bless, and I will see you next time. Don't forget to check back for daily stuff on my website.